Hey friends, welcome back to Math Defined. Today we're talking about something called cross-sections. And honestly, this is one of those topics that feels tricky at first, but once you see it, it clicks. Here's the big idea. A cross-section is the shape you get when you slice through a 3D object. Think about slicing a loaf of bread. You don't just get bread, you get a shape. That's exactly what we're doing today with 3D figures. By the end of this lesson, you'll be able to look at a slice or a cross-section and tell me what 2D shape it creates. So grab your notes and let's get started. Let's warm this up with food because everyone understands slicing food. If I slice a banana straight across, what shape do you see? Right, a circle. Now think about that round cake. If I slice it horizontally, I get a circle. But if I slice it vertically, I get a rectangle. Same cake, different cut, different shape. So every time you slice something, you're revealing a flat 2D shape inside a 3D object. That's a cross-section. Here's the official definition written in math language. A cross-section is the 2D shape formed when a 3D object is sliced by a flat plane. Here's the shortcut I want you to remember. A 3D shape sliced forms a 2D shape. Even though we start with something solid, the result is always flat. Let's test this with a rectangular prism. A vertical slice through the middle of this rectangular prism forms a rectangle. But a vertical slice through the corner forms a different 2D shape, a triangle. So notice what's happening. The same solid with a different cut gives us a different cross-section. Now let's take a look at a triangular prism. If I slice this one vertically straight down to the base, what shape appears? A triangle. If I slice it vertically from the top to the bottom, what do you see? A rectangle. And if I slice it horizontally like this, what shape is formed? Another rectangle. So the same prism can give me two different cross-sections, just depending on how I cut it. Quick pause here. If this lesson is making sense so far, go ahead and tap the like and subscribe buttons below so that you can keep learning with me on Math Defined. And yes, subscribing is totally free. All right, let's keep going. Now let's slice a pyramid. If I cut a square pyramid straight across parallel to its base, I get a square. If I make a slanted cut like this, I get a trapezoid. And here's an important rule. If a vertical cut goes through the vertex and the center of the base, the cross-section will always be a triangle. Let's move on to a cone, like an ice cream cone. If I slice it straight across parallel to its base, I get a circle. If I slice it straight down the middle from the vertex to the middle of its base, I get a triangle. So again, same object, different slice, different shape. Now let's take a look at a cylinder. If I slice it horizontally, parallel to the base, I get a circle. With the cylinder lying on its side, if I slice it straight down the middle, I get a rectangle. So the direction of the cut controls the shape of the cross-section. That right there is the big idea of today's lesson. So which cross-section was easier for you to visualize? The triangular prism or the cone? Drop a green heart and let me know in the comments. And if you want guided notes and practice worksheets, you can find them at mathdefined.com. Thanks for watching. If this lesson helped you understand cross-sections, please take 1 second to help support Math Defined. Tap like, hit subscribe. It's free and helps you keep up with new lessons. I'll see you in the next lesson. And as always, keep math awesome.